In part 1 of this video, we fully explored the throttle and the power controls of DCC++. Now let's move on to the layout section of the interface. As you can see, my layout is fairly complex. It contains 7 sidings, 9 turnouts, 3 crossovers, 2 double crossovers, and 2 reversing loops. The first reversing loop can be seen in the middle of the layout itself. The second is on an elevated track that is represented by the small separate inset graphic at the bottom left. Hitting the I key toggles the display of the elevated track from the inset graphic to the main layout, giving you a more accurate and complete picture of the actual railroad. But I prefer to keep the inset graphic of the elevated track in a separate section, since the full layout graphic is otherwise very cluttered when the elevated track is shown in its true position. The main purpose of the layout graphic is, of course, to keep track of and control the direction of all turnouts and crossovers. As you can see, each turnout is represented by a series of bright yellow tracks and dim yellow tracks. The bright tracks indicate the direction the turnout is currently thrown, in this case turned, and the dim tracks represent the alternate route, in this case straight. To change the direction of a turnout, simply move the mouse near the switch point when the cursor turns to a hand and simply click. The bright yellow lines turn to dim and the dim yellow lines turn to bright, indicating that the track has now been thrown in the opposite direction. Click on the turnout again and it is thrown back in the original direction. Double turnouts and crossovers work exactly the same way. Just point and click. Here is an example of one of the double crossovers in action. You can even control the turnout in the elevated section of the track directly from the inset graphic. In addition to controlling individual turnouts, the DCC++ interface also supports the concept of routes, in which multiple turnouts can be thrown at the same time. But instead of using numbers to represent individual routes, the interface uses 2 types of buttons and color-coded graphics. Route buttons of the first type are located below the graphic layout. Each button is labeled with a descriptive name indicating the specific route it will set. Let's start with the button labeled Inner Loop. If you hover over this button, the route is highlighted on the layout in green and red. This provides visual confirmation of exactly which tracks and turnouts are part of the route. In this case, a simple inner loop is revealed. For turnouts, green indicates a switch that is already thrown in the correct direction, such as this one. In contrast, red indicates a switch whose direction will be changed when the route is activated, such as the 2 at the top. If I now click the Inner Loop Route button, the system sends DCC signals to the actual layout, throwing all required turnouts to the correct direction for this route. And, as the base station confirms each turnout is switched, the layout changes those turnouts from red to green. In addition, the route button itself lights up, indicating that this route has just been set. The button will remain lit as long as all the turnouts that comprise this route continue to be set in the correct direction. For instance, if I change the direction of a turnout that is not part of the inner loop route, such as this one, nothing happens to the button. But if I manually change the direction of one of the inner loop routes, one of the inner loop turnouts, you can see the inner loop route button goes dim. If I manually turn it back, the inner loop button does not actually light up again, even though if I hover over the inner loop button, you can see all the turnouts are green. To get the light to light back up again, you do need to hit the inner loop button a second time. There are many instances where you may want to set multiple routes at the same time. For example, my layout can be configured for 3 non-overlapping concentric loops, so that 3 trains can run simultaneously and unmonitored without colliding. The first loop, the inner one, we've already set. I can now set the middle loop route and the outer loop route as well. As shown, all three route buttons are simultaneously lit, indicating that they are all set and therefore all consistent with one another. Hovering over each of these buttons helps highlight exactly what these three non-overlapping loops are. Of course, not all routes are consistent with all other routes. Rather than set three concentric loops, I can combine parts of the outer loop and the middle loop to form a new loop called the mid-outer. If I hover over that route button, I can see the three turnouts in red that need to be switched. Clicking the button sets that route accordingly. Also note that the middle and outer loop buttons dimmed. This is because those routes are no longer set since the new mid-outer route changed some of the turnouts used by those other routes. However, the inner loop button remains lit, indicating it is still set. Hence, I could still have one train running on this inner loop and a second train running on this combined middle-outer loop. Note that I have quite a number of route buttons. Some are used to simply set the turnouts for the inner reversing loop. Some create double loops by combining the inner and mid or the inner and outer loops. And yet others create more complicated patterns designed for single or double train operation. I also have created a route button simply named Reset, which sets every turnout and crossover to their unswitched positions. Now let's move on to the second type of route button. These are represented by the small green buttons embedded in the layouts near the sidings and the branches. They work exactly the same way as the route buttons below the layout, except that they are not labeled with custom names because their location on the layout makes their route obvious. Hover over any of these buttons and the route is highlighted as usual in green and red. Simply click to set the turnouts for that siding. And as before, the route button lights up, indicating that that route is set. These siding route buttons make multi-train yard work very, very easy. In fact, routes are one of the most powerful constructs in DCC++. During normal operations, I typically find myself using the main route button and the siding route buttons to control my trains much more than setting and resetting individual turnouts. Before wrapping up this portion of the interface video, there are three more features on the main screen that deserve mentioning. The first is the quit button that is next to the power button. This button requires very little explanation. Simply clicking it shuts down the DCC++ interface program, which I won't do right now. Note that by design, quitting the interface program does not shut down track power automatically. As I will describe later, there are operational modes in which the interface is not needed because it is the Arduino base station itself that takes control of the trains. The other button we have not yet discussed is the one labeled Autopilot. One of the main reasons I created DCC++ was to allow for the full unattended control of a complex model railroad. As such, I have programmed the interface with a few autopilot routines of varying degrees of complexity. This button turns on and off those routines. One set of routines automatically backs a train into its correct siding. This makes it easy for me to sideline a train in the background while actively controlling other trains. A second routine operates a train that pulls a cleaning car around the entire layout to clean all of the tracks. The third routine I constructed is the most complicated. It operates 6 trains, randomly selecting 3 at a time, in an interwoven pattern across the entire layout. I have posted a separate video of this fully automated routine if you'd like to see it in action. Of course, it is not possible to fully automate train control unless the system can also detect the position of individual trains. And this brings us to the final feature on the main screen. Note that in addition to the green circles representing siding routes on the graphic layout, there are also clear circles at various locations. These circles represent infrared sensors embedded in the tracks and used by the automated routines to detect the location of trains. Clicking one of the circles manually triggers the sensor and turns it blue. Click a second time and the blue highlight disappears. During normal operation, the sensors are not used, so activating them in this fashion has no effect. But when the autopilot is running, the sensors become very important. Since the sensors and train detection is a complex topic, we'll cover it more fully in a separate video regarding automation. With that said, we've now covered all of the features of the main screen of the DCC++ interface. In the next part of this video, we will explore the rest of the interface as accessed through a series of pop-up windows.